Hello everyone, I am Nitya and I am from CSCC. Now I am giving presentation on multiplexer. Let us know briefly about multiplexer. Let us know what is multiplexer. It is a combinational circuit that receives binary information from one of two power and input data lines direct to it to the signal output line based on selection lines. The selection of a particular input data lines for the output is determined by a set of selection input combinations. A 2 power n to 1 multiplexer will have 2 power n input data lines and n input selection lines and one output. In the selection line combinations determines which input data is selected and output. Let me give detailed explanation on multiplexer. It is a device that takes multiple input signals and selects one of them to send a signal output. Selection is controlled using selection lines and the number of selection lines determines how many inputs can be handled. This is the block diagram of multiplexer. It visually represents how multiple inputs are managed and controlled by select lines to produce one single output. Here D0, D1 and so on Dn are input lines and S1, S2 and so on Sn minus 1 are select lines. And Y is the output. Inputs carry the data to be selected and select lines acts as the address to choose one input and output sends the selected input signal. Now I am explaining some types of multiplexes 2 to 1, 4 to 1, 8 to 1. This is 2 to 1 multiplexer which will be having two inputs and one selection line and one output. And input will be transmitted to one output based on selection lines. This is the block diagram of multiplexer. It has two inputs D0 and D1 and one select line S and output Y. The value of select line determines which input D0 or D1 is passed to the output. If now let us see the truth table. In truth table, if S equal to 0, the output is D0. If S equal to 1, the output is D1. Let us see the circuit diagram of multiplexer. This is circuit diagram of 2 to 1 multiplexer. Here S equal to 0 and AND gate 1 is enabled and AND gate 2 is disabled. So Y is equal to D0. When S equal to 1, AND gate 1 is disabled and AND gate 2 is enabled. So Y is equal to D1. Here we use two AND gates, one OR gate and one NOT gate. NOT gate inverts the select line to produce S bar. And AND gate 1 takes D0 and S bar as inputs. It outputs D0 only if S equal to 0. AND gate 2 takes D1 and S as inputs. It outputs D0, D1 only if S equal to 1. This is 4 to 1 multiplexer. This will be having 4 inputs and 2 selection lines and one output, and input will be transmitted to one output based on selection lines. This is the block diagram of 4 to 1 multiplexer, which will be having 4 inputs D0, D1, D2 and D3, 2 selection lines S1 and S0 and output Y. Now coming to the truth table. For two inputs, we'll be having four combinations. So when S1 is 0 and S0 is also 0, then the output will be D0. When S1 is 0 and S0 will be 1, then output will be D1. If S1 is 1 and S0 is 0, then the output will be D2. Both S1 and S0 are 1s, then the output will be D3. Now coming to circuit diagram of 4 to 1 multiplexer. This is a circuit diagram of 4 to 1 multiplexer. In this we use 4 AND gates and 1 OR gate and 2 NOT gates. NOT gates is used for generating S0 bar and S1 bar from S0 and S1. And each AND gate is responsible for one input. It takes the input and appropriate combination of selection lines. Example, for D0, the inputs to the AND gate are D0, S1 bar and S0 bar, where S0 and S1 is 0. So we use bar. The outputs of all AND gates are passed through an OR gate which combines them into a single output. Now coming to 8 to 1 multiplexer, which will be having 8 inputs and 3 selection lines and one output, and input will be transmitted to one output based on selection lines. And this is the block diagram of 8 to 1 multiplexer. In this, the inputs are 8, D0 to D7, and selection lines are 3, S0, S1 and S2, and output is 1, Y. Now coming to the truth table, for 3 combinations we'll be having 8 combinations. So based on that we determine which will be the output from D0 to D7. And now coming to the circuit diagram of 8 to 1 multiplexer. This is a circuit diagram of 8 to 1 multiplexer. In this we use 8 AND gates, 1 OR gate and 3 NOT gates. NOT gate generates S0 bar, S1 bar and S2 bar, and each AND gate takes an input signal and combination of selection lines. For example, for D0, the inputs to AND gate are S0 bar, S1 bar and S2 bar and D0. In this, the 8 AND gates outputs are combined into an OR gate which combines into a single output. I hope everyone has gained a clear understanding of what I have shared in the presentation. Thank you.